Hello everyone, this is LOURENCE Elumba, and together with my Group 6 partners, in this video we'll be discussing more about the introduction to the travel demand forecasting, which is the modal split. So the modal split or the mode choice is the aspect of the demand analysis process that determines the number or percentage of trips between the zones that are made by automobile and by the transit. The selection of one mode or another is a complex process that depends on factors such as the traveler's income, the availability of transit service or auto ownership, and the relative advantages of each mode in terms of travel time, cost, comfort, convenience, and the overall safety. Mode choice models attempt to replicate the relevant characteristics of the traveler, the transportation system, and the trip itself, such that a realistic estimate of the number of trips by each mode for each zonal pair is obtained. Once again, in this video, we'll be discussing four types of mode choice models that are widely used to estimate how much traffic will use automobiles versus the available transit alternatives. So these models are the direct generation models, trip end models, the trip interchange models, and the lodget models. So our first model is the direct generation model. Transit trips can be generated directly by estimating either total person trips or auto driver trips. This model helps us to illustrate the relationship between the number of transit trips per 1,000 population and persons per square meter versus automobile ownership. This method assumes that the attributes of the system are not relative or not relevant. Factors such as travel time cost, the convenience are not considered here. So, as you can see, sa ato ang curve or sa ato ang distribution table, kay as population density increases, it can be expected that transit ridership will also increase for a given level of auto ownership. So in short, in this model, which is the direct generation model, kay magdepend siya sa usa ka factor, which is the density population. And according sa to ang curve model, sa atong curve model, which is ang x-axis kay mo ang persons per acre, then ang y-axis kay mo ang transit trips per day per 1,000 population. So atong makita dira nga ang model ko na to is ang zero auto per household kay naa siya kanunay sa taas than sa 1 auto per household. So in short, no, kay according dire kay magdepend siya sa population density. If taas daw kuno ang population density niya, then mo taas pod sa daw kuno ang trips, especially sa transit ridership. Meaning, direct ang relationship between sa trips and og sa population density. Alright? But, again, diri sa tuong model is taas jud kanunay ang 0 autos per household than the 1 auto per household. O muna ito ang direct generation. Magdepende sa population density. So, for example, kay determine the number of transit trips per day in a zone which has 5,000 people living on 50 acres. The auto ownership is 40% of 0 autos per household and 60% of the auto per household. So here we are given a population of 5,000 people living on a land area 50 acres. And on that specific population, kay we have 40% of 0 autos per household and 60% of it is the auto percent per household. So to solve that, first we need to calculate the population density, which is the ratio of the population and the land area. So 5,000 over 50 is 100 persons per acres, and that's our population density. And to our para makita nato no ang estimation kung pilay kuan kanang trips per trips on automobile ownership, kung pilay trips sa 0 autos per household o 1 autos per household, kay ato ang gamitong nato ang model nga um, trip curve, no? So here, since kay ato ang population density is 100 man, so ato ara siyang i-point out straight into y. And according sa ato ang data, kay for ay population density of 100, ang 0 autos per household kay naa siya estimated nga 510 trips per transit trips per day per 1,000 population. On the other hand, kay naatay sa tuang 1 auto per household, kay naay kuan na 250 trips transit trips per day per 1,000 population sa ato ang population density nga 100. And to solve the total transit trips for the study zone, which mo man ni itong ipangita, kay i-multiply lang siya nato, no? Separate, isolve nato separately ang 0 auto o ang 1 auto per household. So first is to multiply the percentage kung pilay 0 auto percentage adtong population, dayon i-multiply siya nato sa trips niya, then i-multiply po siya nato sa ato ang aning 5, ang 5 which is the ratio sa population and the 1,000 persons, so 5 siya. And the other hand, since kay ato ang 0 auto household, kay ang iyang percentage kay 40% man, so i-convert nato na siya into decimal, which is 0.4 times 510, kay sa atong estimation kay momento siya ay total trips sa 0 auto ko, no, plus sa 1 auto household, which we have 60% or can be converted into decimal, mahimo siyang 0.6 times 250, which is mo na siya nigawa sa ato ang estimation, then times 5 sila tanan, with a total of 1,770 transit trips per day. So muna siya data nga makuha na to after using the direct generation model example. So the next model that we will be discussing is the trip end model. To determine the percentage of total person or auto trips that will use transit, estimates are made prior to the trip distribution phase based on land use or socio-economic characteristics of the zone. This method does not incorporate the quality of service. Again, same sa trip generation model, trip end model also does not incorporate the quality of service, katong cost, time travel, efficiency, convenient, comfort, and safety. And the procedure follows: generate total person trip productions and attractions by trip purpose, compute the urban travel factor, determine the percentage of these trips by transit using a modal choice curve, apply auto occupancy factors, distribute transit and auto trips separately. So sa unang model, which is the trip generation model, kay we will nakadepende nga to ang data according sa population density. But here in this model, which is the trip end model, the mode choice model is based on 2 factors, which is the household per auto and the persons per square meter. The product of these variables is called the urban travel factor, or the UTF. Percentage of travel by transit will increase in an S-curve fashion as the UTF increases. So ang iyaang curve nato or modal curve nato is letter S yun siya, no? And katulagi ang iyaang factors niya diari or magdepende niya diari kay ang ato ang household per auto o ang ato ang per persons per square kilometer. All right? And ang ilang ilang product is called the urban travel factor, or the UTF. So for our example, determine the percent of residents who can be expected to use transit for a zone with 1.80 household per auto and a residential density of 15,000 persons per mile square. So to solve that, we need to calculate first the UTF, or the urban travel factor, which is 1 over 1,000 times the household per auto, which sa to ang data kay 1.80 times after that kay i-plot siya nato ang ato ang 27 diri sa X, and according sa to ang table or sa to ang curve model kay it is estimated nga for a 27 nga UTF kay we have estimated 40 or approximately 45% of the expected percentage for transit mode split. So the next model nga tong i-discuss is the trip interchange model. So in this method, system level of service variables are considered na, which are including the relative travel time, relative travel cost, economic status of the trip maker, and the relative travel service. So ang katong unang duha kay wala to siya gi-appeal kani sila nga mga factors, but in this model kay gi-appeal na sila. So it is expected that for this model it will become more complicated to calculate the model than atong una kay kani siya apilo naman nato ag mga factors sa atong preference, no? So first we have the two formulas, which is the for the transit and for the auto. So first is the auto, which is the I sub, which is the equation 12.6, and for the transit, which is the 12.7, where kani ang ato ang mga notations, no? Ang ms sub t is the proportion of trips between zones I and J using transit. Ang ms sub a kay proportion of trips between zones I and J using auto. And kaning I sub igm is a value referred to as the impedance of travel time mode M between I and J, which is the measure of the total cost of the trip. So by the way, impedance kay muna siya is equals the in vehicle time per in minutes na siya plus 2.5 times excess time kay in minutes gihapon plus 3 times trip cost in dollars overall income earned in minutes. Then ang ato ang B is the exponent with depends on the trip purpose. Given pa na siya sa atong problem. And atong M is equals T for transit mode. Then A for automobile. So the impedance value is determined for each zone pair and represents a measure of the expenditure required to make the trip by either auto or transit. The data required for estimating mode choice includes, First is the distance between zones by auto and transit. Second is the transit fare. 3 is out-of-pocket cost or auto cost. And the fourth is the parking cost. The fifth is the highway and transit speed. Next is the exponent values B. And then the median income. And lastly, the excess time, which includes the time required to walk to a transit vehicle and time waiting for transferring. Assuming that the time worked per year is 120,000 minutes, all right? So, diri mo ni siya yung mga pinaka-factors kuno in terms sa ato ang pag-travel. Like, in order for us to complete a certain trip from point A to B, kay mo ni siya murag mga factors nga dapat nga ato ang kadalasan nato nga ma-encounter, especially if we are using a transit. Kay magbayad pa ta, dayon maglakaw pa jud ta, din na pa jud mga certain time nga dapat ato i-consider. So mao na siya trip interchange model. So for our example, kay suppose the data shown in table, no, show travel data between a suburban zone S and a downtown zone D. The exponent value for the impedance factors is 2.0 and the median income is $24,000. Determine the expected percentages of auto and transit trips. So, dire sa tuang table kinatay mga data which is distance sa auto and transit, cost per mile sa auto and transit, excess time, parking cost, and speed sa auto and transit. In order for us to solve the ato ang ipangita, kay first we need to calculate the impedance value which is sa auto o sa transit. So using the data nga tong gihatag sa unang nga table, kaya to ara siyang plug in sa to ang formula sa impedance. And here, after plugging in sa ato ang formula, we see nga ang impedance sa auto is 66.25. Dayon sa ato ang impedance sa transit is 56.00. With that, kay mas-solve na dayon nato ang ato ang ang MS sub A o MS sub T, no? Which is ang ato ang the MS sub A, kay mo man na siya ang proportion of trips between zones I and J using auto. Then ang ato ang MS sub T kay proportion of trips between zones I and J using transit. So di ba nakuha naman nato ang mga impedance value sa auto o transit between zones S and D, kay pwede na din nato siya ma-plug in tong mga impedance sa ato ang mga formula sa proportion sa trips sa auto o sa transit. So first, we come up nga sa ato ang proportion of trips between zones S and D using transit, kay naatay 58.4%, no? After using equation 12.7. And for the proportion of trips between zones S and D using auto, kay gamito na to ang equation nga MS sub A or the 12.6 nga equation. So after nato na i-plug in dito ang atong impedance sa ato ang auto, kay makakuha ta og value nga 41.6%. And that's it. Thank you.
Now let's discuss about logic models. An alternative approach used in transportation demand analysis is to consider the relative utility of each mode as summation of each modal attributes. Then the choice of mode is expressed as a probability distribution. For example, there's a formula shown in the screen. Assume that the utility of each mode is where ux is equals utility of mode x, n is the number of attributes, xi is attribute value, which is the time, cost, and so forth. Ai, coefficient value for attributes I, negative since the values are disutilities. If two modes, auto, which is expressed A, and transit, which is expressed T, are being considered, the probability of selecting the auto mode A can be written as P close and open parenthesis A is equals to EUA over EUA plus EUT, which is shown in the screen on the screen. This form is called the LOURENCE model, as illustrated in figure 1210, and provides a convenient way to compute mode choice. Choice models are utilized within the urban transportation planning process and in transit marketing studies. Now let's have an example, which is example 12.11, which uses of LOURENCE models to compute mode choice. As shown on the screen, the utility function for auto and transit are as follows, which is auto is equals to u sub a is equals to negative 0.46 minus 0.35 t1 minus 0.08 t2 minus 0.005 c, and shown also, which is the transit ut is equals to negative 0.07 minus 0.05 t1 minus 0.15 t2, the same value sa auto A, where t1 is equals to total travel time in minutes, and t2, which is equals to the waiting time, and c, which is equal to cost. Travel characteristics between two zones are as follow, which is there is shown that T1, the value of T1, the value of T2, and the value of C in auto and transit. So, let us solve using the LOURENCE models to determine the percent of travels in the zone by auto and transit. So, ang atong buhaton lang is ato alang i-substitute ang katong given nga formula ganiha sa mga value nga gihatag sa travel characteristics sa duha ka zone. So which is 20 and 30, substitute na to, then we will get the answer sa ato ang auto, which is negative 9.70, and atong transit is equals to negative 11.55 as shown on the screen. Using equation 12.9, which is shown ganiha, ang value atong i-substitute again sa E, diba natoy P sub A is equals to EUA over EUA plus EUT. So, mao to siya formula sa ato ang kuan sa equation 12.9. Atong i-substitute to siya sa given nga sa atong nakuha nga value while atong i-solve ni sa auto o sa atong transit, which is the negative 970 and negative 11.55. So we will get the answer for the auto as 0.86 and for the transit is 0.14. Now let's proceed to example 12.12, role of the difference in utilities in the LOURENCE models. Referring to the previous example, which is the example 12.11, suppose a rising fuel prices lead to an increase of $1 for each mode. How will mode shares be affected? So, atong i-compute no balik. So, an increase of 100 cents will lead to new utilities but not new mode shares. So, ang value sa atong UA ganiha is equals to negative 9.70. Ato to siyang i-minus sa 0.05C, which is given ganiya sa formula, and C is equivalent to 100 cents as sa problem nga giingon. So, ang UA is equals to negative 10.2, then the same sa mahitabo sa U trans UT. So, ang mahimong value sa UT is equals to negative 12.08. So, is substitute again nato sa katong formula nga given nga PA is equals to EUA over EUA plus EUT. And sa part pud sa transit, ato lang ilisdan ang auto sa transit nga formula. Then, proceed sa pag-substitute. So, PA is equals to 0.864 and PT is equals to 0.136. The answer does not change because the difference between UA and UT did not change. And it is this difference, not the utilities themselves, that determines PA and PT. This concept is shown in the logit curve of figure 12.10, where the proportion of individuals using transit is governed by the difference UA minus UT. A change would result only if the increase in fuel price did not have the same impact on the cost for transit and auto. Now let's proceed to logit model application. With the total number of vehicle-based trips made in specific time period known from trip generation models. The allocation of trips to vehicle-based modes and likely destination can be undertaken by applying appropriate logit models. This process is best demonstrated by example. Now, let's have example 8.5 logit model of work mode choice. A simple work mode choice model is estimated from data in a small urban area to determine the probabilities of individuals travelers selecting various modes. The mode choices including automobile drive alone, which is DL, automobile shared ride, which is SR, and bus. And the utility function are estimated as UDL is equals to 2.2 minus 0.2 multiplied by the cost of the DL minus 0.03 multiplied by the travel time of DL. Next is USR is equals to 0.8 minus 0.2 cost multiplied by the cost minus 0.03 multiplied by the travel time of shared ride. Next, the last one is UB, which is equals to negative 0.2 multiplied by its cost minus 0.01 multiplied by the travel time, where cost is in dollars and travel time is in minutes. Between a residential area and an industrial complex, 4,000 workers generating vehicle-based trips depart for work during the peak hour. For all workers, the cost of driving an automobile is $6 with a travel time of 20 minutes, and the bus fare is $1 with a travel time of 25 minutes. If the shared ride option always consists of two travelers sharing cost equally, how many workers will take each mode? So, note that the utility function coefficient logically indicate that as modal cost and travel times increase, modal utilities declined, and consequently so do modal selection probabilities, which is shown in equation 8.7. Substitution of cost and travel time values into the utility expression gives, so ato tong i-substitute tong mga formula ganiha para sa DL, which is ang iyahang cost niya sa drive alone, which is ang cost niya is $6, and ang travel time niya is 20 minutes. So, it is equal to 0.4. Sa shared ride pod, ang iyahang cost is $3 and ang iyahang travel time is 20 minutes. Same sa drive alone. So, ang iyahang USR is equals to negative 0.4. UB is equals to negative 0.45. Substituting these values into equation 8.7, which is yields. So, ang PDL is equals to 0.533, PSR is equals to 0.239, and PB is equals to 0.228. Multiplying these probabilities by 4,000, the total number of workers departing in the peak hour gives 2,132 working driving alone, 956 sharing a ride, and 912 using a bus. In example 8.6, forecasting mode choice with the logic method, a bus company is making costly efforts in an attempt to increase work trips bus usage for the travel condition described in 8.5 sa itong previous nga problem. An exclusive bus lane is constructed that reduces bus travel time to 10 minutes and the bus fare is reduced to $0.5. A. Determine the modal distribution of trips after the lane is constructed and the bus fare is lowered. B. If shared ride vehicles are also permitted to use the facility and travel time for bus and shared ride modes is in 10 minutes, determine the modal distribution. C. Given the condition described in Part B, determine the modal distribution if the bus company offers free bus service. Now, let's answer A. After the bus lane construction, the modal utilities of drive alone and shared ride are unchanged from those in example 8.5. However, the bus modal utility becomes, so atong i-substitute again ang mga given nga sa problem, which is 0.5, the cost sa bus, and 10 minutes ang iyahang travel time, which is nag-change siya to negative 0.2. So again, ato ang i-substitute na pod sa ato ang equation 8.7, same gihapon, with 4,000 work trips. So it is given that drive alone makes 200 trips. Shared ride is equals to 900 trips, and the bus rides are 1,100 trips, or an increase of 188 bus patrons from the prediction of example 8.5. Now let's proceed to letter B. With the bus lane opened to shared ride vehicles, only the modal utility of shared rides will change from those in Part A. 2. Ang self-ride, ato na pong usbon ang kanang iyang given nga sa formula, which is ang cost niya is $3 and travel time niya is 10 minutes, which is equals to negative 0.1. Again, atong i-substitute na pod sa atong equation 8.7. So that makes that drive alone is 1,856 trips. PSR is equals to 1,124, and PB, which is the bus, makes 1,020 trips, or a loss of 80 bus patrons and a gain of 224 shared ride using relative to Part A. Now let's proceed to letter C. With free bus fare, the bus modal utility becomes with the other utility unchanged from Part B. So ato na pong i-substitute, wala na cost, then ang iyang travel time is 10 minutes. So UB is equals to negative 0.1. Atong i-substitute again from equation 8.7. So ang PDL is equals to 1,808 trips, PSR is equals to 1,096 trips, and PB is equals to 1,096 trips, which is equals sa PSR or 76 more bus patrons compared with Part B. Now let's have example 8.7, which is legit model of shopping mode or destination choice. Consider a residential area and 2 shopping centers that are possible destination from 7 to 8 p.m. On Friday night, 900 vehicle-based shopping trips leave the residential area for the 2 shopping centers. A joint shopping trip mode destination choice legit model or choice of either auto or bus is estimated giving the following coefficient. So, as shown in the screen na nadira ang following coefficient niya. If shopping center 2 has 4,000 feet squared of commercial floor space and shopping center 1 has 250,000 feet squared, determine the distribution of Friday night shopping trips by destination and mode. The utility function coefficient indicate that as modal travel times increase, the likelihood of selecting the mode destination combination declines. Also, as the destination floor space increases, the probability of selecting that destination will increase as suggested by the positive coefficient plus 0.012. This reflects that the fact that bigger shopping centers tend to have a greater variety of merchandise and hence are more attractive shopping destination. Siyempre, kung dako ang area, mas daghan og tawo nga moadto dito. Note that because this is a joint mode destination choice model, there are 4 mode destination combination and 4 corresponding utility function. Let UA1 be the utility of O2 mode to shopping center 1 and UA2 the utility of the O2 mode to shopping center 2 and UB1 and UB2 the utility of the bus mode to shopping center 1 and 2 respectively. The utilities are, so muna siya ang given, gihatag na ni ganihan dito sa kanang coefficient nga given niya mo na ay 0.6 as auto constant niya nga variable, dayon 0.3 gi-minus siya sa 0.3 para sa auto travel time in minutes, dayon 0.012 sa iyahang commercial floor space in 1,000 of feet squared. So substitute it, then atubot nga og mga value pod nga given. So UA1 is equals to 1.2, UB1 is equals to negative 1.2, UA2 is equals to 0.9, and UB2 is equals to negative 1.8. Again, we will substitute the given answers to equation 8.7. So, PA1 is equals to 0.532, PB1 is equals to 0.048, PA2 is equals to 0.394, and PB2 is equals to 0.026. Multiplying these probabilities by 900 trips gives 479 trips by auto to shopping center 1, 43 trips by bus to shopping center 1, 355 trips by auto to shopping center 2, and 23 trips by bus to shopping center 2. Now, let's have example 8.8. Legit model of social or recreational mode destination or destination choice. A joint mode destination vehicle based on social or recreational trip legit model is estimated with the following coefficient. So, mao ni siya ang variable na to, auto constant, travel times in minute, population in 1,000, and amusement floor space in 1,000 of feet squared. So, sa auto, ang coefficient niya is 0.9, negative 0.22, 0.16 ang population in 1,000, 0.11 sa amusement floor space. At sa bus pod, 0.0 ang auto constant. Travel times is in negative 0.22, same sa auto, but in minutes, it is expressed in minutes. Population, same sa auto, which is 0.16, and amusement floor space, which is equal to 0.11. So, it is known that 500 social or recreational trips will depart from a residential area during the peak hour. There are 3 possible trips destination with the following characteristics. So, as shown on the screen, destination 1 with the sa auto and bus in minutes. Ang destination 1 sa auto is 14 and sa bus is 17. Destination 2 is 5 and sa bus is 8. Destination 3 is 18 minutes and bus is 24 minutes. So in population, destination 1 is 12.4, destination 2 8.2, destination 3 is 5.8. Amusement floor space is in 1,000 of feet squared. So destination 1 is 13, destination 2 is 9.2, destination 3 is 21.0. Determine the distribution of trips by mode and destination. As was the case for the shopping mode destination model presented in example 8.7, the signs of the coefficient estimates indicate the increasing travel time decreases an alternative selection probability. Also increases population, reflecting an increase in social opportunities. An increasing amusement floor space, reflecting more recreational opportunities. Both increase the probability of an alternative being selected. With 2 modes and 3 destinations, there are 6 alternatives providing the following utilities using the same subscripting notation as in example 8.7. So, ato na pong i-substitute ang mga coefficient then sa given pod nga sa problem. So, UA1, so auto destination 1, we have 1.234 and so on. In bus 1, negative 0.326. A2, UA2 is equals to 2.124 and B2 is equals to 0.564. UA3 is equals to 0.178 and UB3 is equals to negative 2.042. Using equation 8.7 with 500 trips, the total number of trips to the 6 mode destination alternatives are katong PA na pod. Then, ang PA1 is 110 trips. PB1 is equals to 23 trips. PA2 is equals to 268 trips. PB2 is equals to 57 trips. PA3 is 38 and PB3 has 4 trips. So now let's go on to example 8.9, forecasting social or recreational mode or destination choice. Consider the situation described in example 8.8. A labor dispute results in a bus union slowdown that increases travel times from the origin by 4, 2, and 8 minutes to destination 1, 2, and 3 respectively. If the total number of trips remain constant, determine the resulting distribution of trips by mode and destination. So, the mode destination utilities are computed as, so same ra gyapon nato as shown sa example 8.8. So, same nga ay ang mausab lang is ang sa bus. So, given nga ang bus 1, B1 is equals to negative 1.206, B2 is equals to 0.124, B3 is equals to negative 3802. Again, applying equation 8.7 with 500 trips given the following distribution of trips among mode destination, PA1 is equals to 119 trips, PB1 is equals to 10 trips, PA2 is equals to 290 trips, and PB2 is equals to 39 trips. PA3 is equals to 41 trips. PB3 is equals to 1 trip. So that's all for logit models. Thank you and God bless you all.
Borrowing utility functions from other sources. In economics, utility function is an important concept that measures preferences over a set of goods and services. If a utility function such that shown in equation 12.9 is not available, then the coefficients for the functions either may be borrowed from another source or derived from survey data. To the extent that the selection of a mode is governed by its vehicle travel time, out of vehicle travel time, and cost, two utility functions may be written as utility function for mode I is equal to in vehicle travel time plus out of vehicle travel time plus out of pocket cost. The following approach for calibrating the coefficient B, C, and D in the equation 12.10 are based on methods published in NCHRP Report 365. In vehicle travel time has a coefficient of B is equal to negative 0.025. Out of vehicle travel time has a coefficient of C is equal to negative 0.050, which reflects the observation that the waiting for a vehicle is perceived to be twice as great as time spent inside a moving vehicle. Cost coefficient D is computed as follows. D is equal to B times 12,480 over divided by TVP times AL, where TVP is equal to the ratio of value 1 travel time divided by hourly employment rate. In the absence of other data, TVP is equal to 0.30. EL, the average annual regional household income. The number in the numerator is a factor that converts a year to cents or minutes, which is 12.48. Example 12.10. A transit authority wishes to determine the number of total travelers in a corridor that will shift from auto to a proposed new bus line. Since local data are unavailable, use of borrowed utility values is the only option. It is believed that the key factors in the decision to use transit will be time and cost. Average annual household income is 60,000, TVP is equal to 0.30, and waiting time is perceived to be twice as long as riding time. System times and cost values are as follows. So, makita nato nga natay variable ang variable, bus, and auto. Ang sa variable, diha makita ang IV, IT, the vet, and the cost. Then, ang sa bus is 36,100. Ang sa auto, 28 at saka 320. Determine the proportion of persons who will use the new bus line. B is equal to negative 0.025. Kaning negative 0.025, muna siya in vehicle travel time. C is equal to negative 0.050. Kanang negative 0.050, muna siya out of vehicle travel time. So, to determine the proportion of persons, D is equal to B times 1248. Ang 1248 muna siya constant. Over TVP times AI is equal to B, ang value sa B, ang 0.025 times 1248 over 0.30 times 60,000. So, pag ato na siyang i-compute, makuha na to ang value nga negative 0.00173. 80 is equal to 0 since the problem stated IVTT, OVTT, and cost sufficiently explain mode choice. The utility functions are U then O2 is equal to B times IVTT plus C OVTT plus D cost is equal to negative 0.025 times 20 plus negative 0.050 times 8 plus negative 0.00173 times 320 is equal to negative 1.454. For U bus is equal to B times IVTT plus C OVTT plus D cost is equal to negative 0.025 times 30 plus negative 0.050 times 6 plus negative 0.00173 times 100 is equal to negative 1.223. The proportion of travelers using bus is computed using equation 12.9. P then bus is equal to AU bus over AU bus plus AU auto is equal to A is negative 1.223 over A negative 1.223 plus A negative 1.454 is equal to 0.557. Makuha na ang 0.557, i-compute na siya sa calculator using gamit ana nga formula. Thus, this model predicts that 56% of travelers will use the new bus line. Example 12.14. Using local data to improve utility coefficients. In example 12.13, suppose 10 residents at the local Department of Motor Vehicles are given a survey where they asked the following two questions. What is your hourly salary and what would you be willing to pay to shorten your travel time by 1 hour? Kanang data nga nasa ubos kanang residents, hourly salary, amount residents is willing to pay to shorten travel time by 1 hour. So, makita di ang 1 to 10 muna siya itong residents, hourly salary 8 to 40, then ang kanang amount residents 3 to 24 muna siya yung makuan sa atong pangutana, muna siya ang kanaang data nga nakuan sa questions. So, para makuha nato makitang solution, atong gamiton ang 3 questions. Kaning use the local data to re-estimate the proportion of travelers using the new bus line. B. Interpret the reasons for the change in proportion. C. Indicate whether the sample of 10 residents likely represents the region as a whole. So, mo man ni siya atong solutions. Kaning use local data to re-estimate. So, makita na, magamit ta sa formula nga atong na-tackle ganina. So, itong B is times 1248. Ang 1248 ha, constant, over TVP times EL is equal to 0.025 muna siya ang value sa B times 1248 di over 0.50 times 60,000, then makuha ato nato ang negative 0.00104. Thus, the utility functions U then O2 and U bus and the bus proportion are follows. So, mao na siya ang computation. Pag ato na siyang i-compute sa calculator, makuha nato na ang mga value ana. Dili na kay nako kan siya task-on og explain kay gamay gamating kaayo ang ako ang naasa report. Thus, the proportion using the bus changed from 55.7% to 12.0%. Interpret the reason for the change in proportion. In the original assumption, TVP was assumed to be 30%, whereas in part, local data was used to calculate a TVP of 50%. The higher value of TVP in part means that additional cost has a lesser this utility than what was originally assumed. This change is evident in the new value of the cost coefficient D, which had an original value of negative 0.00173 and a new value in part of A of negative 0.00104. The new value signifies that increased cost will have less of an impact on the utility than was the case in the original problem. Examination of in-vehicle travel time and cost for each mode shows that the bus generally offers lower cost, whereas the auto offers lower travel time, because the cost parameter D has less of an impact of utility in part than the utility problem. The relative importance of lower cost is diminished in part. Accordingly, it is not surprising that the mode share of bus drops in part relative to the original problem. Last, indicate whether the sample of 10 residents likely represents the region as a whole. It is unlikely that these 10 residents represents the region as a whole. The average hourly salary of the 10 residents is 10.20, which, assuming 2,080 hours per year, yields an average salary of 41,808, which is considerable smaller than the regional salary of 60,000. A survey with a greater sample size conducted at multiple locations rather than only the DMV should attract a more representative population. Such data would need to be examined to determine whether the calculated value of TVP should be modified.
Example 12.15. Adding a mode-specific constant to the utility function, referring to example 12.13. Upon inaugurating the bus service, the percentage of travelers that use the new bus service is actually 65%. Follow-up surveys confirm that the coefficients B, C, and D, which were used to estimate potential bus service, appear to have been correct. However, the survey suggests that a further incentive beyond time and cost for using the bus is influenced by the availability of laptop outlets at each seat and a complimentary beverage service. Given this added information, explain how to modify the utility function to reflect on the added amenities and to reflect the influence of added amenities. So, here is the solution. Because the coefficients B, C, and D do not include additional features that favor bus usage, a mode-specific coefficient, A sub I, should be included in one of the utility functions. This term may either be a positive coefficient that is added to the bus utility function or a negative coefficient that is subtracted from the auto utility function. Using the former approach, simply add a constant value, which in this example is 0.3885, to the bus utility function in order to yield the required 65% of travelers using the bus. So here it is. P bus is equal to E U bus plus 0.3885, which is the constant value, and all over EU bus plus 0.3885 plus EU auto. So here is the value of U bus and the value of U auto. So E is equal raised to the negative 1.223 plus 0.3885 all over E is equal to negative 1.223 plus 0.3885 plus E is equal to E plus E raised to negative 1,454 is equal to 0.650. Thus, the bus utility function is rewritten and the auto utility function is changed as follows. U bus is equal to A bus plus B IVTT plus C OVTT plus D COST. So U bus is equal to 0.3885 plus negative 0.025 IVTT plus negative 0.050 OVTT plus negative 0.00173 COST. So for the modifying a logit model for changes in service parameters, if the value of the IVTT, OVTT, or COST parameters has changed, then the new mode share PI can be calculated from the original mode share PI and the change in the utility function value as shown in the equation 12.11. So 12.11 is shown in here, where PI is equal to proportion using mode I after system changes. So PI is equal to proportion using mode I before system changes. So the delta UB is equal to the difference in utility functions values UI new minus UI old. So example 12.16, applying the incremental logit model. The Regional Transportation Agency in example 12.15 is considering an investment in signal preemption or for transit vehicles, which would reduce the in-vehicle travel time for bus service from 30 to 25 minutes. All other service amenities will remain. Determine the percentage of travelers who will use bus service if this investment is made. Solution. Equation 12.11 may applied as follows. So P bus is equal to 65%, P auto is equal to 35%, delta U bus is equal to U bus new minus U bus old. So delta U bus is equal to close and open braces 0.3855 plus negative 0.025 IVTT new plus negative 0.050 OVTT new plus negative 0.00173 cost new close bracket minus open bracket 0.3855 plus negative 0.025 IVTT old plus negative 0.050 OVTT old plus negative 0.00173 cost old. So we just need to input the new, then the U bus new and then and subtract it to new bus old. Since the bus travel is the only variable that has been changed from 30 to 25 minutes, so delta U bus is equal to negative 0.025 open and close parenthesis 25 minus 30. So the delta U bus is equal to 0.125. So the delta U bus is equal to 0, assuming no change in auto travel time or cost. Using equation 12.11, so we must input it, and then the P bus is equal to 0.65 e raised to 0.125, which is the delta U bus, and then all over 0.35 e equals to 0, and then the plus 0.65 e raised to 0.125. So we have here the 0.68. This answer to example 12.16 can also be obtained if the logit model was used with all system parameters and the amenity value A as shown in example 12.15. The advantage of the incremental logit model applied in 12.16 is that knowledge of the mode-specific constant A initial is not required. That's all. Thank you.
Hi everyone, good morning. This is Clyte at Escuadro, and today I am going to discuss the calibrating utility function with survey data. A second approach to determine utility function coefficient is to calibrate the coefficient based on the survey data using the method of maximum likelihood estimation and the software packages such as the SAS and the allogates are available to support maximum likelihood estimation and replace manual procedure presented here. So the utility functions that are best supported in the data are determined through a variety of statistical analysis that represent fundamental components of this calibration process. So here, we can see an example. A regional transportation agency wishes to calibrate a utility function that can be used with a logit model to predict modal choice between bus, auto, and rail. The survey data were obtained by interviewing 7 people identified as person A through G who reported the travel time for 3 modes they considered, such as cars, bus, and rail, and the mode that was selected. Here, as you can see, these are the predicted time that they will arrive at their destination. The auto time in minutes, and the bus time in minutes, and the rail time in minutes. So we are going to solve the utility function in which the formula that will be used is U is equal to B times the IVTT, where B is the constant to be determined from the calibration process, and the IVTT is the in-vehicle travel time in minutes. So a maximum likelihood function may be used to derive the modal coefficient that replicate the observed data. For this data A, perfect function would predict that respondents A to F would select the auto, as you can see in the example, and C to G would select rail, and D and E would select the bus. For respondent A, the utility function is as shown since A selected auto and not for the bus or the rail. Thus, the formula that will be used is L sub A is equal to P sub A times the auto. So the probability that A will select a mode is computing using the equation 12.8 and 12.9, as you can see here. This formula will be used to determine the probability that respondent A will select auto, rail, or bus. So the substitution process equation is into the expression of LA yields the maximum likelihood function for respondent A. And this will be the formula that will be used for the entire data set. Therefore, the maximum likelihood function may be computed as this. Since B cannot be determined, such as L is exactly equal to 1.0, the best possible result is to select a value of B such as L is close to 1.0 as possible. Theoretically, L could be differentiated with respect to B and equated to 0. However, the nonlinear equation that result usually necessitate the use of specialized software to solve. Plot L versus B is shown in figure 12.11, and the value of B is equal to negative 0.1504, maximize the L. Thus, the utility expression based on the data collected about user behavior is U multiplied by the 0.1504 times the in-vehicle travel time. Then, several tests may be used in logit model calibration to determine which parameters are statistically significant. One example is likelihood ratio test, defined as equation A as 2 times L times L times B. So this is the figure 12.11 11 that I am talking about the plot of maximum likelihood function versus where the L times 0 is the log likelihood value when all model parameters are 0. So LB is the log likelihood value of the calibrated model. The quantity is compared to the chi-square statistic with k degrees of freedom. For example, k is equal to 1 since the model has non-zero parameter. And then L times 0 is equal to negative 7.69 since with no parameters, the probability of choosing each model is 1/3, and with 7 respondents, 7 ln times 1/3 is equal to negative 7.69. Then LB is equal to negative 0.81 since ln times 0.0033 is equal to negative 5.81. See in the figure 12.11. Thus, the likelihood ratio test is equal to 2 times L times 0 minus the L times B, so this will be equal to negative 2 minus 7.69 minus negative 5.81, and this is equal to 3.76. So because the 3.76 is less than the 5.03, which can be found from the Excel function chi initiatives, the parameter B is not statistically significant. In practice, either more data would be more collected or another utility function would be devised. And that would be all. Thank you.